Hi, my name is Marek Zorawski, and I am an MD PhD student at Duke University, and I received PhRMA Foundation's 2024 Predoctoral Fellowship in Drug Discovery. The way that I got into science was through, honestly, really great teachers and mentors throughout my life. I would say that I didn't really even enjoy science until about the 11th grade. And in the 11th grade, I had a really great chemistry teacher and a physics teacher who really changed my trajectory. And they made me super interested in science and eventually medicine as well. My PhRMA Foundation funded project involves looking at this process called RNA splicing. So movies are edited eventually after all the film has been shot. But in order to know which edits make it to the final film, there has to be some kind of selection process. And our cells do something very, very similar. The DNA has all the information. It's like the full roll of film. But then it's when the RNA is made, it's the kind of the intermediate before we make our proteins in our cells. The RNA has to make decisions about which parts of the film come together and get stitched together into the final blueprint of that RNA that then gets made into the proteins. So that stitching process happens every day in our cells, in all cells, healthy and diseased. And the stitching process, like I mentioned, is called RNA splicing, which can go awry in disease. So it can be dysregulated, especially in cancer. And so what I study is a specific form of RNA splicing that occurs in cells in prostate cancer, and it can actually lead to worse disease for patients. And so my research tries to find a kind of signal on that film roll that can actually stitch things together incorrectly and actually try to hit it, try to block it with potential new therapeutics. If we can block the incorrect stitching of the film that leads to treatment resistance in prostate cancer, maybe we can revert it to treatment sensitivity to the drugs that we already have in clinic that we know work well, but just don't work well when the film is incorrectly stitched. The PhRMA Foundation Award has already helped me in numerous ways to expand my research. And one way that it has helped me is that I can now focus on my main thesis project, my main work in the lab for my PhD that centers around this PhRMA Foundation Award because no other grants in our lab actually look at the project that I'm looking at. So this is a really new research direction, and it's not only new for our lab, it's also new in the field to even look at splicing modifiers that target RNA in cancer. As part of the award, there are funds to go to conferences. So I've already used the funds allocated for this year at the RNA Society meeting, and I can't wait to see the connections that I get to make at these conferences, and also through the Award Foundation itself, other researchers doing similarly really interesting work in drug development and discovery. Previously, this was quite a few years ago now, but I was awarded a Fulbright Fellowship to go do research in Poland on cancer biochemistry as well. And that kind of helped fuel my love of basic research in cancer and trying to understand it. And most of my family lives in Poland, where I did my Fulbright, and it was a really good cultural connection for me to go back to the land of my heritage and to speak Polish with other scientists who are trying to achieve the same goal of cancer research and drug development and trying to make lives better for patients both here and abroad. So that was a really big moment in my career. It really changed, I would say, my whole trajectory. I now want to kind of have an international scientific career spanning both countries of the US and Poland, as well as others if they happen. But kind of realizing that science doesn't happen in a bubble, and it's important to have collaborators across continents even to have that exchange of ideas and learn new things. I would say the best piece of advice that I've been given and that I continue to give to other incoming graduate students, medical students, is the importance of mentorship. It takes many tries to find someone who you can really find that inspires you, that you want to model your career after. But when you do find someone like that, it can just make the science flow. It can make ideas flow, and it can make you just a better scientist, a better, more motivated person to do good in the world. And it's honestly the best piece of advice that I've gotten. My future career aspirations are to become a medical oncologist who also runs a lab looking at new ways to target cancer.